there are certain legal implications that the whole production of the app will count in the whole production of the app. For example, collateral systems, tracking systems where, in fact, you sign in with your Ghana card ID, so we know who you are. You can't run away anywhere. You can be tracked anytime. So I don't think you shouldn't really be afraid. In fact, if any default happens, we have to take the blame and we have to resolve it. Thank you.
Okay, judges, please, any more questions? Okay, Team Sprout, I think you are clear to go. Please, a hand of applause for them. A hand of applause for them. They have done well. And this is not to discourage loaning in any way or to encourage loaning in any way, but if you're in a quick phase and you need a quick cash, you know you can go to them and they will sort you out. However they trust you to get the money back is between the two of you. So, at this point, Team Koda Code, please come on stage. And as you are coming, make sure your presentation is with the tech team so we make this as seamless as possible. Thank you very much. Team Koda Code. Thank you, audience. Hey, you people, you have fun, so impress us. Don't let the clapping go to waste.
Okay, so good day, everyone. We are here representing Team Codes Code, and I'm the person of Animal, Isaac Kobo, together with
Isaac Sechi, Adam's Miracle,
Achala Elijah,
and Divine, who will be presenting. After getting to know of the problem statement, we decided to create a remittance system, which will help people in the diaspora be able to translate money to customers in other countries. Now, we needed to have a very solid objective. From the description of the challenge, we needed to tackle the issue with architecture, making sure that our infrastructure is very scalable and also our application will be very fault tolerant. We consider at least 3 microservices, which we went beyond it. We have our asynchronous processor, containerized deployment, our retry and idempotent APIs. We also focus on the security aspect of it. We have tamper-proof webhooks, which do not make people interact with our payment flow. We also touch on the observability and traceability of our system. In the financial landscape, we have to have insight into every transaction that is being processed. Now, with our system, we'll be able to know every single thing that goes on, either a transaction was successful or it failed. All right, so these are what we intended of doing, having a very resilient design, an asynchronous distributed processing, a very strong traceability, and developer-first APIs. Next. Our services can be decoupled into different services. Our system, we have the API gateway, which handles our validation, and also our routing of the requests to the different services we have available. We have our orchestrator, which handles the entire business logic and call the various tools. We have our logger, which tries to have insight into the various systems events that's happening. We have our Docker Compose, which handles our deployment, and also if you want to make it very scalable, we have a Helm chart which will help you deploy into Kubernetes stack. We have our Kafka, which handles our asynchronous processing, and also Postgres, which handles our data persistency to track the transactions that are being recorded by our system, and Prometheus to get the metrics from our application to the user. Next. Now, this is the architecture of our system. We have the API endpoint, the API gateway, which requests go into which the orchestrator calls the various tools required to process the transaction. Every data will be logged into the Postgres database, and everything is asynchronous, and all events are being handled by Kafka for real-time event streaming and queuing system. Next. Now. Okay, good. So for resilience, we consider fault isolation, where we have different services. So if one fails, the other ones will be persistent. Our idempotent API, making sure that every transaction is very unique. And also we have the worker retry policy. Sometimes you initiate a transaction and doesn't go through, and if that's the case, then the system should be able to retry it without compromising security. We have persistence and also fallback payment processor. Next slide.
Okay, so in order to ensure we have strict security at the client side, because our application will be interfaced by developers, so we implemented 4 main security architectures for the client, and then we are using JSON Web Tokens to encrypt the user's payload at the client side, from the server side to the client side, and decrypting to see that. And then we are using HMAC webhook validation. So what this does is, whenever a payment is sent, right, there are 2 approaches to see whether your payment is successful or not. You can do either polling or this approach, which is the optimum. So polling is, you keep on hitting the server. Is my request ready? Is my payment successful? My payment successful, but provided your network goes off, you don't get the response that your payment was successful. So we use this approach whereby it uses events. So you just make the payment and forget about it. And then you give us your endpoint that you send the response to. So when the payment is successful, we just send it to you, irrespective of your internet connection. So we keep on trying until we get a 200 response from your server that you've processed our payment. And then we are handling secrets management. And also we use, in order to prevent client-side, cross-site request forgery and DDoS attacks, we use these 2 main libraries for that. And the CORS library helps to restrict the kind of URLs or endpoints or origins that hit our servers. So to allow only clients' URLs to hit there, and then origins to also prevent the DDoS attacks. And then in order to see what is actually happening, because this is a financial system, so we must be able to monitor from beginning to end and to see everything that is going on. So at the interfacing side, we used JSON logs to do that, and then at the API gateway side, we use Prometheus to be our data warehouse and Grafana to do the data visualization. And my partner will demonstrate that during the demo. So yeah, the same thing. And then you see, payment systems are supposed to be immutable. We should be able to track and see everything that goes on. So we make sure that every key event that happens alongside during the payment processing, we made sure it is immutable. You cannot delete, update, or do anything with it until so the key features for the front end, and we have a landing page obviously, and then we used a row-based authentication. So it's only admin, a person with an admin privilege that will be able to access the admin panel, and then someone who is not authorized to do that cannot be able to do that. We are supporting multi-currency accounts, funding flows, and transaction history. Because it's a remittance system, you should be able to top up in any currency at all that you want to send to, based on the country you are in. And then we have admin analytics, audit logs, and system health. My partner will demonstrate them to you, which are very robust. Yeah, and my colleague mentioned that we are focusing on developer-first approach, because these two will mostly be used by developers and also alongside customers. So our documentation, we use public Swagger to do the documentation and also Postman collection. And then we have a clear onboarding process, and then in order to test that our system is very resilient, we used libraries, or we wrote scripts to really test if our system will be able to withstand high pressure. And then we realized that indeed it is able to. And then my partner will explain in details when he's demonstrating how the resilience is being handled. So my partner, Divine Kwanzaa, will do the live demo and do further.
So this is the dashboard for the Swift Remit application. Over here, you can see 3 different accounts in the 3 different currencies. The first one is an euros account, the second one a dollar account, and then the third one a CD account. Let's go through the process of funding any one of the accounts. Let's fund the euros account. So when you press the fund account button associated with the euros account modal, euros account card, a modal pops up and then the currency is shown to be euros. You enter an amount, let's say $300, and you press the continue button. Once you press the continue button, you see a list of payment options to use to fund the account. Let's select the bank transfer account, the bank transfer method, and then press continue button. A list of bank accounts are shown below, and then you press the one that you have. So let me select the Chase account and then press continue. So over here, I'll enter a routing number. And then my account, my Chase bank account number. Once I press the review transaction button, I see an overview of the transaction I'm about to make. I go through them and see that everything is all right. I agree to the terms and conditions over here and then confirm and fund the account. Right here and there, the funding account process begins. So right now, the account funding has been initiated. The whole process is an asynchronous process. So what happens at the backend side is that our payment gateway, our API gateway receives this receives this event that someone wants to make an account. It receives the account details and everything, and then it sends the event to Kafka, and then our orchestrator routes this. Our orchestrator is a listener of the Kafka event, so it routes this job to the payment service provider, and the payment service, and then the payment service itself processes this account. So once I refresh the feed, you see that yes, the account has been funded. Let's go through the remittance flow, and then I'll show you some logs. I'll show you how we are keeping track, how the whole asynchronous communication between the various backend services we have take place. So let me press the send remit now button. So over here, it brings the modal, and then I select the account I want to transfer money from. I'll select the euros account again, and then a card over here shows me my current balance. I enter the amount I want to send, let's say 400 euros, and then continue to the receipt PN's details. I'll just fill this one with autofill, so we speed up over here. The destination country, the recipient is in Ghana. So I press the continue to provider selection button, and it brings me to these 2 popular payment providers in Ghana. So let me go with mobile money. Mobile money, it will show me the various mobile money options we have here in Ghana. Let's go with MTN mobile money, and then continue to account details. I'll enter the account details of the person we are going to transfer the money to. Continue to review, and it gives me an overview of the transaction I'm about to make. I review and go through that everything is all right, and then agree to the terms and conditions stated below, and then send the money. This one, yes, so the whole transaction process is going through, and once the whole process is complete, an event is sent to our Kafka queue, and then our orchestrator routes it to the relevant services, and then they process it. So when I refresh my feed, you see that the amount I sent has been deducted from the account that I used for the transaction. And when I go into the history over here, this current history is for the USD account. Let me switch to the Euros account, and you see that yes, a record of the transaction has been played, is visible over here. This will give me more insights into the transaction itself. Let's move on to the admin panel. So I show you guys what the audit logs we are keeping track of. So at the admin panel, over here you see an overview of the whole system. This is supposed to be if Swift Remit's in-house dashboard we use to monitor our whole business and then operations. So over here, when I move on to the audit logs, you see that there are a lot of transactions that has taken place, and each of them have an action associated with it. These actions are sent by the API gateway. When a transaction is being made, the API gateway routes it to the orchestrator, and then the orchestrator to Kafka, and then Kafka, the relevant service consuming from Kafka then takes in the processing and processes the transaction. Let me also open a more detailed logs over here so you guys can see what has been going on here. So whilst developing, we ran a bunch of tests in the back, and then for certain transactions, you see that we tried with a lot of other mobile money payment providers, and then for some transactions, you see that yes, some failed, and then the reason for failure was correctly logged in our audit log service. So this is the actual remittance transactions, and then the audit logs, all of them are over here, and they are being tracked as required. So let's move on to our Docker container for you guys to see the various services we have actually implemented and are currently running for this demo. So we have the Prometheus service. You can see the statistics of the Prometheus service as we were running the demo. Actions were taking place, and the Prometheus was receiving requests and then processing them, and you can see from the
Codex Code, please be preparing to wrap up with your presentation.
All right.
Thank you.
All the services are here for you to see. So yeah, that's it, and these are the key achievements we made during this hackathon. We were able to develop a fully containerized event-driven architecture for scalability and resilience, and it was designed we designed the event-driven architecture to be able to recover from failures when there is high loads or traffic and our systems are not really scaling on their own. We also used enterprise-grade security and then observability.
Codex Code, a minute more, and then you'll be cut short.
Observability stack to make sure we protect our data and then monitor performance as well. So yeah, that is the end of our presentation. Thank you, everybody.
Thank you so much, Codex Code, for your wonderful presentation. Judges, please, over to you. Any questions?
Thank you very much for your presentation. Again, I'm personally excited when someone tries to attack a problem and solve it, right? Now, this is what I want to know. What is the major frustration of the Ghanaian money sender and receiver that you are trying to attack? Right, the major frustration that is not being touched yet that you want to work on.
Okay, so the major challenge we want to solve is downtimes when there is high traffic. There are a couple of banks that are known for that, but there are a lot of traffic on their servers. You cannot withdraw your money. So that's the major thing we focused on solving using the solution.
Regardless of that, we try to have a very robust architecture which really scales. So independent of the amount of traffic we are having, we'll be able to accommodate for that. And also for the payment system that we are having too, we have different countries' transactions that can also pass through our system.
Okay, so for instance, I won't go to CBG and find a long queue, people trying to do MoneyGram. Normally they'll tell me the network is down. That's the issue. Okay.
All right, thank you for your presentation. I think it's a good work. Did you conduct any stress test on your system?
Yes, please.
Okay, and what was the results?
Okay, so we use Chaos Monkey, which is Netflix industry standard way of testing your infrastructure. We use Chaos Monkey. This is the industry way of testing your infrastructure. If you're going to microservice architecture, to get to know that if a particular service breaks down, it doesn't trigger others to also break. So you got to know that when a particular system gets down, it automatically reboots to fill up the space over there.
Okay. My second question is, what is the most innovative feature in your solution?
Okay, sure. So for the transaction flow, that one is already there. A lot of firms are doing that. Right. But what we intended of doing is we have an AI system at the back end which tries to audit the various logs. Let's say a transaction is being made, it runs through a XGBoost algorithm to get to flag it. Hey, if this transaction is very anomaly, we only tackle anomaly. So if very anomaly, then we just have to redirect a person to intercept as a human in the loop process to get to know that, hey, this transaction is actually required, and then maybe the person will just call the let's say if you are a company, you have different workers. So the worker will just call the person who's making the transaction, get to know that, are you the one making this transaction? If it's here, they just proceed with that.
Do you have competition?
Pardon?
Do you have competition?
Do we
Do you
have
have
competition?
competition?
Your application, is it unique, or, do you have competitors that already exist in the market that you want to address?
We have competition, but we also have upper hand. Yeah.
Okay, so well done, guys. You really follow the case, and then you address the problem. Each item I put there, you address it. So you've done well. You've done well, and I've actually had the chance to see the source codes. It was well documented as well. And then your APIs, are they working? The Swagger, they're available.
They are working and they are available. And
Okay.
we're not even able to integrate all the APIs in our front end. For remits, we have refund APIs, a lot of other APIs we are not able to show in the UI. But then my colleague over here will just show the Swagger docs for you guys.
Okay, so how are you storing your HMAC secret?
How
are you storing your HMAC secret for the encrypted data in transient data?
So currently in the Docker environment, we are just using an environment variable.
Variable, okay.
Okay. So these are APIs.
Okay. For how long have you known each other? Did you build a team purposely for the hackathon, or you've been working?
I've been working with these guys since like second year on various projects, I think everywhere.
Okay, because you carry some maturity.
Thank you very much.
And I like the fact that you are using Kafka framework for your, building real-time data pipeline, which is very good. Congratulations.
That was Code's code. A round of applause for them as they take their seats, guys. They have done well. A round of applause for them. Okay. Next team, Quens. Quens. Please be prepared to get up on stage. Quens. A round of applause for them. Okay, so as you take the mic, kindly let us know your names and programs of study. And because you are time conscious, please note that you have 10 minutes to put your message across. Thank you very much.
Hello, please, I'm Ransford Okon, and I'm a final year biomedical engineering student.
I'm John Anamboy, final year computer engineering student.
I'm Bafwa Saibidi Akon, also in computer engineering final year.
Please, I am Stephen Ajay, a final year biomedical engineering student.
And we have at the back there Livingston Aivo. He's also a final year biomedical engineering student. We are Team Queens. Globally, there are about 100 plus payment gateways. Ghana is evolving, and many students, many developers are building fintech apps, which are basically financial technology applications, like the ones we see in banks and in e-money. We were trying to build a payment system or a payment platform as part of this hackathon, which we called a Coins app. But we realized a problem along the way. As developers, we try a way to integrate a lot of payment gateways into these apps that you are building. For example, we don't want to use Stripe, we don't want to use Paystack, we want to use Express Pay in our platform. Heidelberg Materials would want to go cross-border with their transactions and many other payments. That was the problem. Then, what's the solution? We came out with a unified or a single API that targets all these payment gateways. So with a single API, you can integrate all these payment gateways in your app without any hurdles. And one other problem that we faced was that all these Stripe, Express, Paystack, they have different responses. So it means that the developers are finding it difficult to integrate, and you have to manage them individually. And that came up with a Coins Payment Gateway API. So my colleague will run through the architecture and everything.
Yes, so we initially had an idea and we had to pivot quickly. So our idea was that we were building Coins, as he said, but now we pivoted to building a payment gateway aggregator. Now, as developers, we know very well that it's very difficult to handle all these payment gateways. We have abstracted that from you, and we are handling all the payment gateways, giving you a unified API interface for you to be able to have access to multiple payment gateways. Don't manage the code, we'll do that. We'll scale the payment. Just interface with us. So we'll give you a demo. So because of time, we've done a recording that we'll show you, but after that, if you want to test it, we can also show you that. So this is mainly for developers and companies who want people to focus on the payment while they focus on their business logic. Right? So we abstract the payment for them. So as you can see the APIs, so developers can come and log in, then they can input their payment gateway credentials, they can manage escrow. And once I was at the back, I heard are there competitions? This one, there are a couple of people who are trying to do that, but they don't have automatic escrow built inside, which we have provided, very unique. Yes, so we'll quickly go, as you can see, if you are going to add a payment gateway, these are the responses. So this is the payload that you need to provide to us. What payment gateway? What are the public keys, the secret keys, and all those things? You provide it to us. Then we'll use AES 256 encryption to encrypt it. Now, we are using Laravel at the backend. And interesting, Laravel always encrypts these things. If we are using AES 256 encryption, Laravel encrypts these things using the API key. So we can always do rotation. Anytime we change the API, the app key, it's the encryption will be redone again. So we are able to rotate the encryption, so you can't really break it, right? So let's quickly go and test it out. So we've added a couple of payment gateways initially. So we've added Paystack, we've added our details there. I'm a developer, so we are approaching this one as a developer, right? So we've added Paystack, we've added Stripe. Now let's see how you'll be using the payment. You don't need to handle the code. Let's see how you'll be using it. So as you can see, so right now where we'll be going is we want to go and execute a payment for you to test. We'll be testing the escrow and then straight payment for you to see how it works. So we are going to charge. Now, if you're a developer and then you are integrating into our system and you are going to debit from a user, you want a user to make payment, you just come here, hit our charge endpoint, then you select the payment gateway that you want. Then you input the amount, right? Then you input the currency. This one we are using Stripe. That's why we are using USD, right? So Stripe works mostly in the Eurozone. So then you just key in the details, so you can forward it quickly so that they will see. Let's look at the response that we get. Now, this particular demo in particular is for escrow, right? They pay, will not release the money until there's a confirmation that the money is received. So we allow a window, maybe 7 days, you decide. Okay. So now we've executed the payment. Now you see the status. The status is escrow. That means that the money hasn't come yet. We are holding the money until there's a confirmation. Until there's a confirmation. So let's see how we'll confirm. Okay. So over here, we'll come to transactions. We want to see the kind of transactions that we are having. We select the status of transactions. We are storing transactions for observability, right? So we look at the transactions that we are having. We see that the recent transaction that we kept inside is there, escrow payment. Now we want to release that payment. We want to release that payment. So we use the transaction ID. So developer just have to copy the transaction ID, come and put it, hit the endpoint, that release payment. Then let's see what happens. Payment is released. You can see funds released from escrow, right? So when you initially, I tried to visit my Stripe account for you to see how the money has come, but the network wasn't good. So yeah, these were previous things that we've done. So you see that it's actually working. It's actually working, right? Now let's go and test with a different payment gateway. Now we are going to test with Paystack. So let's see how Paystack works. We are going to do the same thing, but this time not escrow, just straightforward payment. Let's see how it works. How easy it is for developers to use our system. Now, we are changing Stripe to Paystack. And let's say you want to receive 1 million Ghana cedis. Yeah, some nice business. You want to receive 1 million Ghana cedis. Then, Paystack, the currency, GHS. That's Ghana cedis, right? Then we input the things. And if you look at the API documentation, you will see the required fields and the fields that are not required. Right. Okay. So fast track it and let's see how things are going. Good. And the callback URL. Paystack usually require a callback URL. So you pass in the callback URL and we will, after we execute that, we will route the person back to your app's callback URL that you have given us. Right. So the configuration is very good. So let's look at the response that we are getting.
Tim Quains, please be preparing to wrap up with your presentation. Thank you very much.
So this is the last. So we'll look at it. So you see, we are giving them the checkout URL. Then they will now retrieve this one and display it to the user. Then the user can complete the payment. They are not handling code. We are doing it for them. So look at that. So you can imagine as a business, if you're using our service, you can easily scale without worrying about payment and without worrying about different payment gateways that you would like to interface because we have them. All you need is to input your credentials and they are safe. So, and this is a health checkpoint for you to see whether our service is up and running. So basically that's what we've done and I'm sure maybe there will be a lot of questions, so we'll be there to answer them.
Okay. Thank you so much for your wonderful presentation. I don't know if I should say fortunately or unfortunately for you, but the judges have given me the power to ask you all for the remainder of this session one very simple question. And that is, from your presentation or from the work you've done so far as a team, what is the one thing on your application which gives it a competitive advantage over the others in the market? So they are strategizing to give us a very good answer that the judges will find appealing. But then please do that for us quickly.
Yes, so this is B2B, right? And if you're a developer and you've ever integrated with payment gateways before, you understand the problem that we are solving here, right? So you don't have to handle the code. The uniqueness here is that we handle the payment for you. Just give us your credentials. Just go there as a developer, give us your credentials. We handle the payment, and we have automatic escrow. So if you don't want the payment to go automatically, we hold the payment until there is a confirmation that the person has received the item. Then you hit our endpoint and release it. And you can set days, and then we have background workers there that will check the time. If the time is up, it will automatically release all escrows, right? So it really gives us a competitive edge, because I'm sure a lot of businesses don't want to be handling so many payment gateways. And if they have the opportunity to interface with different payment gateways, they will do it. Yeah.
Okay. Thank you so much for your answer. So you may take your seat now as we call on the next team to come and give us their presentation. But as they take their seats, Managing Director of Heidelberg, you weren't here, but I believe the team was trying to tell you codedly that whatever problem your business is facing, you should give it to them, they can do it for you. You weren't around, they said it, so I'm just relaying the information to you. Thank you. Next team is Team Crypt. Please come on stage and let's see your work. Team Crypt, kindly hurry on stage. A round of applause for them, a round of applause for them. Thank you. Please take the mic. Start your presentation.
Good day, everyone. This is Team Crypt, comprising of level 200 biomedical engineering students, and we are here to present on our project for this hackathon. My name is Nana Echada Komensa, and I'm here with
Udri Abua, a second-year biomedical engineering student.
And we have Nana Boating Adadi at the back, and also Michael Ajimai, who will be joining us soon. So imagine Kofi, a businessman who makes routine transfers every week. He transfers to KD Ventures on Mondays to Starlight Ventures on Saturdays. Meanwhile, hackers have been closely monitoring his accounts for a while, waiting to strike. So can businessmen like Kofi and 4 million others closely, can their accounts be safeguarded whilst doing their daily transfers and so on? Or would they be prone to security risk and cybersecurity attacks? So this is where our Team Crypt comes in. So our goal is to employ a special feature known as the quantum encryption system to enhance key generation, which will be further discussed in our presentation. And this would promote safety and secure real-time financial transactions. Thank you very much.
Okay, so the background of our presentation is based on a research that we made on quantum-empowered payment systems with real-time fraud detection. So according to the IBM, 2015, there was 3 million fraud detected, but then the estimated analysis that we made it clear that by 2025, you have 10 trillion dollars fraud detections. Please, the next slide. Okay, so the key features of our of what we developed is the quantum key generation. That is the unhackable transition IDs. And then also we have the AI fraud detection. That is the machine learning, and then the large language model, which catch anomalies instantly. And we have the chaos engine that simulates the attack. So with this one, we don't have a real data, but then we have a demo data of which we feed into the chaos engine. So the chaos engine is like a fraudster trying to attack the system. The next one. And we have the live dashboard that monitor everything in real time. So the transactions that are being made, the fraudsters at particular locations are all displayed on the Streamlit dashboard. So this is part of the Streamlit dashboard. Go back. So this is the overview of the Streamlit dashboard. So you have the analysis of the money transferred, the transfer rate, and then the key gen rate, and then also the security promises. So this one, the security promise is 97.8%, which is mostly secured. So there is a question here. There is a statement. Imagine if every financial technology can see what goes on at their back end real time with just a dashboard powered by Streamlit coded in Python. So the Streamlit dashboard is coded in Python to actually monitor how transactions are being made in the space. The next slide. So this one is actually the organogram of everything that we did. So Kofi is at the front end, and then behind the front end is the back end, where simulations and everything goes on. So we have the quantum model, which generates the quantum keys to make the transaction ID very secure, of which it can be hacked. And then we have the machine learning and then large language model engine. The large language model engine is being fed with data to train the machine learning model so that it will be adaptive over time. And then we have the chaos engine. So as I said, this is a demo. So the chaos engine actually feeds the whole system with some anomalies for the fraud to be detected. And then we have the Streamlit dashboard. That is the main one to display all the transactions and then the frauds being detected. And now, if everything is secured, then the payment is made successful. So this is also the mobile view of the application. And then with this one, comparing the quantum encryption to the traditional one. The traditional one is actually breakable, and then the quantum is not breakable in the sense that the quantum key distribution is based on photons, and then the photons, they change forms. So when an abnormal activity or there is a hack in the system, they just change form and then breaks the transfer and alert the sender that there is actually some fraud going on. And then this is also displayed on the Streamlit dashboard. And you have the fraud detection. So as I said, the AI adapts to the transactions, the numerous transactions going on, noticing the route. So if it branches to any route that is not, that is not supposed to go through, then the AI and then the large language model, which is adaptive, that has adapted over time through many transactions, will actually help to detect. And then also it is resilient in the sense that with the traditional system, we have manual testing. But then for the quantum encryption, since the AI and the machine learning model is included, it is automatic. So as the transactions are being made and then the sum of data increases, then the machine learning model also adapts, and then actually it is self-healing in the sense that it works based on the transactions being made over time. The next one. Okay, so there will be a question that, is quantum encryption really unhackable? Some will be like, then why is it that people don't use it? Because if it is unhackable, then hackers will actually work in vain. Yes, it is unhackable. quantum encryption leverages fundamental principles of quantum mechanics. So as I said, a key is being sent from one place to, okay, so let's say bank A is sending money to bank B. And then the transaction ID is being secured.
Please be preparing to wrap up with your presentation. Thank you.
Is being secured with a quantum key. The hacker can't notice the actual quantum key to decode the transaction ID to actually break the system and then get the money out or out of the transaction. And then this was also discovered on the World Economic Forum this year, May 2025. So unlike the classical encryption, which relies on computational complexity, quantum key distribution detects eavesdrops by exploiting the fact that measuring a quantum state alters its irreversibility. So this actually needs a very advanced technology to put the work in place. Now, Geneva and then China are using this quantum encryption, and I think we can also adapt as time goes on. The next slide. Okay, so this slide is displaying the names of our team members. So we will move on to the live demo for us to know how the fraud detection and then the Streamlit dashboard actually happens. So we are signing into our system. We are using a hard-coded logins so that we all see how it works. Yeah, so this is basically the normal transaction page that we all have. Now what we are trying to solve is the fraud. So we move on to the Streamlit dashboard to see how everything works over there. So there is a payment which will be initialized. And then going to the Streamlit dashboard, you can see that this is the fraud detection part, whereby all frauds are being detected. So let's move to another interface. Yes, and then this one is Quantum Security Control Center. So it generates 847 keys per minute. And then it is 99.9% secured. So this one, see the performance increases over time from I think 2 move to 4 and then now 10. So that is the Quantum Encryption Control Center. And then we move on to the payment analytics. When transactions are being made, how they reflect over there.
Team Crypt, your time is almost running up. Please wrap up in the next 1 minute.
All right. So move to, you are done, right? Okay, so basically this is how the Streamlit dashboard actually works in connection with the front end to simulate payments and then to track anomalies in transactions. Thank you.
Judges, please, do you have any questions for them?
Okay, so gentlemen, what role did you play in the entire project?
All right, so with the research and then analytics part. So actually the data that we are using, we got it from Kaggle, so that's where we got the database.
All right, so in software delivery lifecycle, we'll call you a product owner, but you should try and simplify the solution, okay? Because you took all the time trying to explain the solution proposal, okay? You took quite a complex approach, but in explaining, you should try and flatten your explanation, okay? But generally, good presentation and good solution.
I want to build on that what my colleague said, and that's maybe silly, simple question. Whom would you sell that to? Who is your customer?
Okay, so the basic targeted customers is actually the banks who transact huge sum of money.
Okay, makes sense.
All right, thank you for your presentation. I want to ask, did you simulate any attack or fraud in your testing?
Yes, so we have a hard-coded card details, which is not supposed to be used. So it's like we have the basic card details and a wrong one. So when you open the dashboard and you try to send money, when it reaches security check, it stops. It doesn't validate the payment because that card details that you entered isn't the right recipient.
Okay.
So you can demonstrate that. Please wait. So it's coming to enter the payment details. When you see that, it will reach the security check and nothing will happen. Yeah, so with this one, the hacker will actually be waiting for a response. Continue to click on the process payment, and nothing will happen. So it is being blocked behind.
All right. How fast is your system?
Okay, it is very fast because yes. So it is fast in a sense that if the system generates about 847 quantum keys per minute, it means it is 847 times faster than the normal
Compared to what? Do you have any baseline?
Yeah, compared to the traditional system that they use one transaction key.
Okay. All right, thank you.
Thank you, judges. You may please take your seats. Next team, Team Titans. A round of applause for them as they come on stage. Team Titans. Please, let's hurry to stage. Okay. Please take the mic, introduce yourself, your names, and the program of study, and then you may start your presentation.
This is Team Titans. I'm Benjamin Etona Mabuchi, a Computer 3 student and then the founder of PrepCI.
My name is Kwe Mark Tete, a third year computer engineering student and a backend dev on this project.
My name is Owusu Prince, a third year computer engineering student, project lead, research manager, and UX designer.
So I am Prince Adonyaku, the front-end developer, a third year computer engineering student.
All right. So today we are introducing Mr. P. Why Mr. P? We found out that making transactions on campus is very difficult, especially with businesses. If you are selling gope and then you want to take money, you have to write your number, or anytime the user comes, you have to mention your number to the user 05XXSSS before the user can actually pay you. Now, that is no more with Mr. P. We have built a system that allows for very fast transaction, which doesn't even require you to know the number of the merchant or your seller. So, what is our mission? Our mission is to build a secure, user-friendly, fast, consumer and business-focused payment solution that makes life easy. All right. What are we focused on doing? What are the features of our software? We support virtual cards, email, OTP at the moment, a robust API for integration with other software. So if you have a website and you want to integrate Mistral Pay into it, you can easily integrate it into your e-commerce website, your Gobe website, into your student selling website. We also have multiple payment methods. Those are the features of Mistral Pay. Now, we generate a secure card ID for you, which follows the industry standard, using the industry standard algorithms. We also support subscriptions. So if a user wants to subscribe to, say, Spotify, students today want to subscribe to Spotify, but because they don't have the card and going to the bank to take the card is the tedious thing for them, they don't want to do it because it's very difficult. So we are bringing it right to you. From your Momo to Mistral Pay to Spotify, you get your subscription. All right. We have introduced payment link and QR code into our system. Now, if you look at the traditional payments where you have to take the other person's number, enter, please, it's your name, Akosia, whatever, and then you say, yes, that's my number, you can send it to me. It takes very long time for you to be able to process the transaction. But with payment link, we've been able to reduce, the time would reduce down because if you scan, you get a link, click, you enter, confirm, it's gone. QR code, very fast. If you are using the app and you scan the QR code, immediately it just processes and then send it to the user. So we support QR code and then payment link. Those are the very core features. We want the transaction to happen instantly. I don't want to block people in the queue. All right, so there's real-time notification. We have built our software to the point that if you initiate a transaction, it shouldn't take too long for you to receive your OTP. OTP is sent directly to your email for you to just get it and then continue with your transaction. In our software architecture, we've introduced, we've built a microservice architecture which has a transaction service combined with authentication. Then we've built an event system that takes all the events, which is built on RabbitMQ, and then dispatches it to so many workers to process transactions and then emails. Also have retry logic for retrying failed transactions and then load balancing. We also have circuit breakers for transactions that are in the queue for too long and they are retrying over and over again. If you reach your max, which at the moment we set to 5, if you retry 5 times and it breaks, you are out of the queue. You inform the user that your transaction is over. Thank you. So we'll take the demo from here. So this is, every user of Mistral Pay must be authenticated to be able to use the software. So we'll take you through the authentication process and how the user interface looks like. Once you log in, you are introduced to the dashboard, which is your user account. Here you can do so many things. One of the first few things you can do is you adding money to your account. So you can credit your account with a top up. You can transfer money to another user which is using the app. You can also do quick pay. So quick pay is for businesses or even you as an individual. You want to get quick payments, you can just go there and they will show you how that works. You can also withdraw your money from the app. You also have options to add wallets. So you can have multi-wallet system. You have one wallet for your tuition, one wallet for your Gobe seller. I like Gobe though. And then one wallet for maybe your family. So you can do multi-wallets. Let's take a look at how the top-up works. So I want to credit my Gobe account with 1 cedi. So this is going to send a prompt to the user's Momo to authorize the charge. So you enter your phone number, the phone number you want to use for the top up or the crediting. Currency and then your provider. So we support MTN and the other Airtel Tigo. This is powered by Paystack under the hood. So Paystack is taking care of all that for us. So we are building on top of Paystack to be able to charge our wallet. Now, once you click, all right, so the charge has been sent to him, and then he has just initialized it. So, yeah, so he is processing the transaction. Once it's done, automatically the account is charged. I don't know, it's not showing over here, but the balance for Gobe has increased to 4 cedis. It was 3 cedis per, now it's 4 cedis. So once you add money, now you are in the app. Everything works smoothly. Transactions, everything. Now let's talk about transfer. This is a very important part of the application. You select the wallet you want to use to transfer the money to another wallet, then the amount, the currency. But something happens under the hood. Once you initiate a transfer, it is sent to the backend to authorize, to ensure that you, the one sending the money, you are the one who owns the account. No one else owns your account. It also ensures that the other account exists. If it doesn't exist, break it. Then, if your wallet is not, doesn't have enough balance, the transaction doesn't go through.
Please be preparing to wrap up with your presentation. Thank you.
All right, so please enter the other account and then let's go on. Select the new okay. All right, so OTP verification must be sent to the user to verify that he is the one initiating the transaction. In case an attacker by any means is able to get hold of this, you are in charge. You are the one to be able to authorize that a transaction is useful or is authorized by you, or initiated by you. Okay, now you can see that Gobe has been sent to, please, who did you send it to? All right, so the transaction has been sent from one to the other and it's verified. So if you go to the transactions page, you will see, okay, this is still, okay, completed. So now the transaction has been completed and has been taken over there. So if you go to the home page, you will see that the wallet will be well debited. And then, just smooth, that's how smooth it is. Now, let's come to the final and the last part of it, which is very interesting, the quick pay. This is for both consumers and businesses. The quick pay works like this. You select the account you want to receive money in. This is just a basic feature. There's so much we can do with the quick pay logic we've built. So the quick pay, you select the amount you want to receive, and then once you initiate that, it generates a QR code for you. This QR code contains a token. This token is well secured with the HMark algorithm. Now, we do not store the HMark because we are sure that with the HMark, if you send a token and the HMark doesn't match it, and it doesn't match our HMark secret, it's an invalid transaction. So no one can steal money from your account with some malicious link because everything is secure. All right, so here he is coming to scan. He has taken a picture of it on his phone. He's coming to scan and then confirm. So the account that he wants to use to pay. So this is how businesses work. Once you just scan, you just enter your account number and then click pay, and then it will be sent to the Gobe seller without you having to ask, Gobe seller, please, are you Akosia Ma, whatever? And then he would That's it. We are done. Transaction completed. Smooth and simple.
Okay. Thank you so much for your presentation. Judges, please, any question for them?
Thank you very much. I like the fact that with these online payment things, reliability, security, efficiency, they are very key features, and I think you have all that in your solution. What plans do you have to scale your solution globally?
So I can come up with plans right now, but if I think more, I can come up with better plans. Now I can see that one way we can scale this is introducing more currencies. That is one, because if we want to be able to transfer across border, means that we should be able to have real-time exchange rates and then convert transactions. That is one of them. Another one is we have to stress test our software to the point that no amount of stress will break anything. Even though this is just like a hackathon and we've been able to build something, we wish to be able to test this to the point that, like, even if there is a DDoS attack, our system can survive. This is just a business solution. But given the right amount of time, we can build something that can scale around the whole world without any limits. Thank you.
Apart from these features, given more time, what additional things can you add to your system or to your solution?
Okay, so one of them that is in mind right now is if you look at the quick pay, you can, at the moment, you have to enter the amount you want to receive. But businesses in the real world, they don't do that. You enter the amount you want to pay. So if I buy Gobe 5 cedis, someone else will buy Gobe 6 cedis. I should be able to enter the amount I want to send to that business. And then if I enter that amount and then click send, everything should just work smoothly. The business will receive notifications 6 days from.
Thank you for your presentation again. I think that your team should merge with Code's code. I don't know how you feel about that, but I think if you guys work together, you will do better. I don't know, or you think you should be able to expand what you have now on your own. I don't know.
Thank you very much. Unity is strength, so we are ready to collaborate with them and build something that can scale. Thank you.
Judges, please, any more questions?
What is the limitation of your current solution? Just one challenge.
Yeah, the limitation is it's only limited to Ghana cedis. For now, that's what just came up.
All right, thank you.
Welcome. Okay, team lead, please switch your team lead. Kindly stay behind on stage. And the rest of the teams up there, please, your team lead should kindly come and join us on stage. Everyone else can go and take their seats. Please, those at the back, select one person from your team to come and represent. Join us on stage briefly. Please, let's do that quickly. Okay. Thank you all for your presentation. This is going to be a quick fire question from the judges. So in 1 minute, I'm going to ask you the question, and then you explain as briefly as possible in 1 minute, please, your answer to the judges and then the audience. So what is the one thing on your application which gives you a competitive advantage over the others? In 1 minute. Please let's do that quickly.
First of all, I'd like to say LendMe is the first of its kind.
Sorry to cut you short. Before you answer, please mention the name of your team. Thank you.
Usual from Team Sprout. First of all, I'd like to say LendMe is the first of its kind, offering, considering the functionalities. We only have one other competitor that offers one functionality of ours, but not even to the fullest, which is the peer-to-peer marketplace. For them, what they do is they take investment groups and then puts them on platforms for other people to hop on board. But what we are doing is linking real-time users and peer-to-peer users instead of organizations to users. That's one thing that sets us apart from our few competitions.
Thank you very much. Please pass him the mic in 1 minute. The name of your team and then the competitive advantage.
So my team is Titans, and the competitive advantage is the speed.